1.2 operations with real numbers. We're going to be add, subtracting, multiplying, and dividing real numbers, and then evaluating exponential expressions and using the order of operations to evaluate expressions. So first and foremost is adding numbers. These are rules that you may or may not like to use if you're a mental math person. If you're a calculator person, you may not ever use this, but if we're adding two real numbers with like signs, so either they're both positive numbers or they're both negative numbers, we want to add their absolute values, so what's the stripped down value of that number, and attach the common sign to the result. The second rule is, let's say they're unlike signs, so one's plus and one's minus, a positive number and a negative number. We're going to subtract the lesser absolute value from the greater. So you take the bigger number minus the smaller number and attach the sign of the number that has the greater value. So if the bigger number was negative, you'd put the negative onto the answer. Subtracting two real numbers. So this is for subtraction signs now. If you're going to subtract a real number from another real number, we want to add the opposite. So think of it this way. If A is a number and B is a number, and we're subtracting them, instead of subtraction, let's change it to add, and then change the sign of B. So we're going to make B opposite. Now it's a negative because it was a positive earlier. So we turned it into an addition problem. And now what rule does it follow? Well, I have a positive number and a negative number, so now I'm at rule 2 here when I'm adding unlike signs. So let's put this to the to good use. We're going to add these two real numbers. So I have negative 84 and a positive 14. So one's minus and one's plus. I'm going to follow the second rule that says to subtract their absolute values. So 84 minus 14. And I'm going to attach the sign of the bigger number. The bigger number between 84 and 14 is 84, and the sign on 84 was negative. So at the end, I just want to make my answer negative. 84 minus 14 is going to give you 70. Attach the sign of the bigger number, so it's negative 70 for my answer. Down here, the second one, I have a negative and a negative. So those are same signs, which means I'm going to add their absolute value, 138 and 62, and I'm going to keep their sign. So both of them are negative, so on the end of my answer, I want a negative. And when I add these two together, I get 200, tack on that negative. Down here, I have a positive and a negative, so I'm following the second rule. And I'm going to subtract the numbers, their absolute value, so 3.2 minus 0.4. And I'm going to attach the sign of the bigger number. The bigger number between 3.2 and 0.4 is 3.2. which is positive, so I'm going to attach that positive to the end of my answer. Subtracting these is going to give me 2.8, and I want to make sure that it stays positive 2.8. And the last one, same signs. So I'm going to add their absolute value, so 26.41 plus 0.53. And the sign that's common between them is negative, so I want to make sure my answer has a negative on the end. When I add these together, I get 26.94 and tack on the negative. Okay, so that was all addition. Now let's look at some subtraction. 9 minus 21. Now the rule for subtraction is to turn it into an addition problem. So this is 9 minus 21. I'm going to change the minus to a plus, and I'm going to take the opposite of 21. 21 here is positive, so I want to make it a negative 21. Now I'm adding two numbers that have unlike signs. So what I'm going to do is subtract their absolute value, 21 and 9, and I'm going to keep the sign of the higher number. What number is higher, 9 or 21? Oh, that'd be 21, and the sign on 21 was negative, so I want to make sure my answer stays negative. 21 minus 9 is 12, but I tack on the negative. The second one, subtraction again. So I have a negative 2.5, but I want to change subtraction to addition. And I want to change the sign opposite here. So it was negative 2.7, now it's going to be a positive 2.7. I'm adding things with different signs. So again, I want to subtract 2.7 minus 2.5 and keep the sign of the bigger number. 2.7 is a bigger number, so it's a positive 2.7. I keep the positive. And once I subtract these, I get 0.2. You may have heard a song before. And I'm going to sing it now, but please promise not to cringe. It goes something like this. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then you'll be exact. So what that song is saying is the rules. The same signs, you add and keep their sign. Different signs, you subtract and keep the sign of the higher number. So same signs, add and keep their sign. Different signs, subtract and keep the sign of the higher number. That's for addition problems. So that's why we're changing all of these subtraction problems into addition problems. So again, let's change this one. For minus negative 11, I want to change to addition and take the opposite of the sign of 11. 4 plus 11, that one's easy, you get 15. Down here, keep the first number the same, change subtraction to addition, and change the sign of 5.1. It's positive, so I'm going to make it negative. I'm adding numbers with like signs, so same signs, they're both negative, same signs. I want to add the numbers, 21 and 5.1, and same signs add and keep. So I want to keep the negative, they're both negative. When I add 21 plus 5.1, I get 26.1, but I keep their negative out in front. So those are the 4 answers to subtracting the real numbers. Now, what if I am adding and subtracting fractions? Ignore all of this goofy stuff in this PowerPoint. I don't even remember when I was making it a couple years ago. I was a real nut job. I'm way more mature now, but I have all sorts of crazy stuff like fractions, because everyone hates fractions. They say frac when they have to do it. And then this is common, the wrapper, and it's pointing to C and C because they're common denominators. So I was all goofy. But when you're adding and subtracting fractions, you need like denominators, otherwise called common denominators. Okay, if you have a common denominator, if the denominator is the exact same, you can add the numerators. So don't add the denominator. I call that dad. Don't add denominator. But we do want to add the numerators, a plus b, and keep the denominator the same. Same goes for subtraction. Okay, it'd be the exact same if there was a subtraction sign here instead of an addition sign. So if we come over here and we try to solve 5, 6 plus 7, 6, they have common denominators, so I can add the numerator and keep the denominator the same. 5 plus 7 is 12. I always want to reduce my fractions, so I kept 6 in the denominator. Please don't add 6 plus 6 and get 12. That would be incorrect. 12 divided by 6 is 2. What happens though when they don't have common denominators? So I have a 10 and a 2. I need to find a common denominator, so which means that I need to find the least common denominator, the least common multiple between 10 and 2. And if you're unsure, you can list the multiples. So the multiples of 10 would go 10, 20, 30. Multiples of 2 would be 2, 4, 6, 8, 10. Oh, I found one they have in common, and it's 10. So I know that 10 is going to be my common denominator. Well, this guy already has 10 in the denominator. How do I get 5 halves to have 10 in the denominator? Well, I want to multiply by what to get up to 10? If I multiplied by 5, that would give me a denominator of 10 here. If I do it in the denominator, I have to do it in the numerator because I don't want to change the value of this fraction. So what I do in the top, I have to do in the bottom. So now I still have 3/10 minus, but this fraction has changed forms. 5 times 5 is 25, and 2 times 5 is 10. Now that they have a common denominator, I'm going to subtract. 3 minus 25 in the top, denominator stays the same, and 3 minus 25 is negative 22 over 10. If I can simplify it, I want to. So I can divide each of these by 2. Negative 22 divided by 2 is negative 11, and 10 divided by 2 is 5. So I want to make sure my fractions are in simplest form. Okay, and 3.5 plus 4 3/8. These are mixed numbers. Mixed numbers I don't personally like. I'm not sure why they teach you them in grade school because we don't use them in high school. So what we want to do is change them to what they call improper. However, improper is a dumb name because they're completely fine. There's nothing wrong with improper fractions. So in order to do that, I want to multiply the denominator by the whole number. So 2 times 3 would give me 6. And then I want to add that with the numerator. 6 plus 1 is 7. My denominator stays the same here. So it's a 2. For my other fraction, again, I'm going to multiply 4 times 8, get 32, plus 3. It's 35, and my denominator stays 8. Now they don't have the same denominator, so I need to turn them into a common denominator. I know that I can get 2 up to look like 8, and I don't have to change 8 at all. So in order to get 2 up to 8, I need to multiply it by 4, and what I do in the bottom, I have to do in the top. So now this becomes 28 over 8 plus 35 over 8. So I need to add 28 and 35. So I get 63. And I don't want to add the 8s. Do not add denominators. 63 over 8, which can reduce into a mixed number, but we don't want to change it into a mixed number. I like improper fractions, so you don't really have to do anything here. There's not a number that goes into 63 evenly and also goes into 8 evenly. Multiplying. Multiplying becomes a bit easier than adding and subtracting. So something I want you to keep in mind that when you're multiplying a positive number times a positive number, your answer is positive. 2 negatives multiplied together, it's still a positive. But when you have a positive and a negative, then that's when your answer is negative. Okay, so basically if you have an odd number of negatives, then answer will be negative. That'll come in handy when we're multiplying more than just 2 numbers. So let's jump down here to examples. Negative 6 times 9. Just tell me right off the bat, what would the answer to this problem have to be, positive or negative? Well, it fits this category of 1 negative and 1 positive. So my answer is therefore will be negative. And then I just take 6 times 9 and I get 54. Down here I have 2 negatives, so my answer is going to be positive. And then 5 times 7 would be 35. It gets more complicated when I have 4 numbers. Multiplication is commutative, which we'll talk about what that means next section, but Basically, it means you can multiply in any order, and your answer will be the same no matter what. But I want you to follow this rule that see if we have an odd number of negatives. So let's count how many negatives we have. We have 1, 2. Well, 2 is not an odd number. So my answer is going to be not negative because I have an even number. So my answer will be positive. And I'll take 5 times 3, and I get 15. And then times 4 times 7. So 15 times 4, that'd be 60. And I have 60 times 7, which, let me get my calculator. $420. And the bottom one, I have 1 negative. 1 is an odd number, so I know my answer is going to be negative. It doesn't matter what order I do this in. I can take 3 times 7 to get 21. 21 times 10 is going to give me 210. Make sure it's a negative. The same goes for fractions, however, they're a little bit different than addition and subtraction. So on your fractions, you can multiply straight across. The tops times the tops, and the bottoms times the bottoms. So multiply the numerators, multiply the denominators. It was different for addition and subtraction because you didn't do anything with the denominators. You never added or subtracted them. Okay, so negative 3 times 11, that'd give me a negative 33. 8 times 6 is going to give me a 48. Down here, I have a negative 10 times a negative 3, so that's positive 30. And then 13 times 5 would be 65. Dividing real numbers. Okay, so just like we changed subtraction into addition, we can change division into multiplication because dividing is the same as multiplying by the reciprocal. Well, what the heck does reciprocal mean? Reciprocal means that you flip it. So you flip the fraction. Don't make it negative, don't make it positive, you just flip it. So what was ever on top now becomes on the bottom. So for instance, let's say I had 2/9. The reciprocal of 2/9 would be 9/2. The reciprocal of 7, well, 7 as a fraction is technically 7/1. So the reciprocal would be 1/7. Let's try one. I have negative 30 divided by 5, which you could probably type in your calculator, but if we're doing it without a calculator, I want to keep the first number the same, change division to multiplication, and find the reciprocal of 5. Remember, that's 5/1, so I'm going to flip that to be 1/5. Well, negative 30 as a fraction is just 30/1. So now I have two fractions being multiplied by each other. I can multiply the top numbers, negative 30 times 1, and I get negative 30. I can multiply the bottom numbers, 1 times 5, and I get 5. Now I want to simplify this fraction. Look what it ends up being. It's the exact same as what we started with. So I'm just showing you that this is why the reciprocal works. Negative 30/5 can reduce to negative 6. When you're dividing, the same rules apply as multiplying negative and positive numbers. So a negative and a positive make a negative when you're multiplying and dividing. Okay, down here, I have fractions. Remember, fractions are part of the real number system. They're also always going to be rational. Okay, so I'm dividing two rational numbers. I have to change the mixed number first. So I multiply 2 times 4 and get 8. And then I add it with 3 and I get 11. So what I'm really doing is taking 5/16, dividing it by 11 over the denominator here was 4. Let's change this into multiplication. So your first number stays the same. Change division to multiplication and flip 11 over 4 to be 4 over 11. Now when I multiply straight across. 5 times 4 is 20. 16 times 11 is 20. 16 times 11 is 176. I can reduce this. I know that they're both even numbers. So if I divide them by 2 to start off with, this would be 10 and this would be 88. I can divide by 2 again and I'd get 5 over 44. And now that's as far as it will go because nothing can go into 5 and nothing can go into 44. Let's look at one more. I have negative 10 divided by 0. So negative 10 as a fraction is negative 10 over 1. And 0 as a fraction would be 0 over 1. So we're going to change multiplication to division multiplication, and we're going to flip this fraction into 1 over 0. When I multiply it, I get negative 10 over 0. So if I try typing that in my calculator, it's going to show as an error because we cannot divide by 0. If 0 is in the denominator, it is no good to have 0 in the denominator, but it is okay to have 0 in the numerator. Here we have 0 in the denominator. We can't divide by 0. That's a serious no-no. So 10 divided by 0 is undefined, or you could put NA. Okay, exponential expressions. Here's an example of a raised to the nth power. A is going to be called the base, and n is the exponent. N just means how many times are we multiplying a by itself. So here we have a times a times a times a n amount of times. I don't know what n is, so this could go on forever because n is a variable, so there's n factors of a here. So for instance, the base in this problem is negative 3 and the exponent is 4. So what that's saying is take the number negative 3 times itself 4 times. So when I do that, I have 4 negative numbers, so my answer is going to be positive. 3 times 3 times 3 times 3 would give me 81. Something I want you to notice is the parentheses. In this example, they are collecting the negative 3 inside, so the negative sign is part of the base. But in this problem, the negative sign is not part of the base. It's not covered or surrounded by parentheses. So what it's saying is take 3 times itself 4 times, and then out in front, you're going to have a negative. Okay, so 3 times 3 times 3 times 3 is 81, but there's that negative there, so my answer would be negative 1. So what this is saying is that the negative sign is not part of the base. Down here, I do have that negative in the base because it's got parentheses. and my exponent is now 3. So I take -5 times itself 3 times. I have 3 negative numbers. 3 is an odd number, so my answer is going to be negative. And 5 times 5 times 5 is going to give me 125. So it doesn't matter where the negative is to come up with your answers. So for instance, I had parentheses with a negative inside, and my answer was positive there. I had parentheses with my negative side, or with a negative sign, and my answer was negative. So the parentheses are just telling you what are you multiplying by itself. The number in negatives tell you whether or not your answer is negative. Same goes for fractions. I mean the exact same thing. So this doesn't mean just take the 2 times itself 3 times. It means take the 2/5, that whole quantity in the parentheses, and multiply it by itself 3 times. If I'm multiplying fractions, I can multiply straight across. 2 times 2 is 4, times 2 again is 8. 5 times 5 times 5 is 125. Over here, we went from exponential form and evaluated it. Now I want you to turn this into exponential form. So what would this look like as one of these guys? Well, find out the base by saying what's being multiplied by itself. Okay, -7. And then how many times is it being multiplied? 1, 2, 3. So 3 is my exponent. Down here, what's being multiplied by itself? That'd be 7. It's 3 times, but I have a negative out in front. What happens when it's being multiplied by itself, but there's nothing else written? So how many times do you see the base? Well, I see 1/4 here, and I see it 1 time. So my exponent is actually 1. We typically don't write that. So 1/4 by itself in exponential form is just 1/4. Order of operations. You guys have all heard of PEMDAS. It's parentheses, exponents, multiplication, division, addition, and subtraction. But I don't like exponents. I think it's incorrect for a couple different reasons. And you can tell your teachers that they've been teaching you wrong all along. I don't care, have them take it up with me. But it's wrong in my case because it says to do parentheses first. Well, there are other types of groupings other than parentheses. You know, there's brackets and different things like that. So it's not just parentheses. That's the first reason why it's wrong, because there's other types, and I call them grouping. So the first step in order of operations is to do any groupings first. And groupings can be parentheses. They can be brackets. They can even be fraction bars. So an example of a fraction bar being a grouping is when I have 2 numbers in the top, like A and B, and divided by C. Well, it's saying, hey, the top is being grouped together. You have to add A and B first before you can do the bottom division. So a fraction bar is a type of grouping. The next part in GEMS is exponents. So the E does say the same. And that could be like a to the n, 4 to the 3rd power, something like that. The M. The M stands for multiplication and division. So this is another reason I don't like PEMDAS, is because it kind of looks like you're supposed to do multiplication first every time and then do division second every time. Well, that's not true. They're on the same level of importance. So M means multiplication and division. Okay, if they're on the same level, what happens if they're in the same problem? Which one do I decide to do first? Do I do the multiplication first? Do I do the division first? How do I know? So the one part I want you to add to this is it's multiplication and division from left to right. That's how I know what one to do first. Okay, it's not that multiplication always comes first, or it's not that division always comes first. It's whatever number is farthest to the left, like reading a book. And then the last one, S, it does stand for subtraction, but it also means addition. So subtraction and addition, again, from left to right. Okay, so the way I like to think about this is in terms of the army. Now, I'm going to completely butcher this. I don't know if this is true, but let's say the highest order or ranking in the army is general. Okay, so anytime the general gives a command, you have to do his command first. Okay, no matter if like the lower level people are telling you to do something, you have to do the general first. And then maybe there's lieutenant. Okay, lieutenant is the second highest ranking. If you take care of the general's orders, then you can go on to the lieutenant's orders. If there's no general, if the general doesn't give a command, then you want to do the lieutenant's command first. Okay, and then maybe there's sergeant. Sergeant is the third ranking. Once you take care of the general, once you take care of the lieutenant, then you can do the sergeant's command. But maybe you have multiple sergeants and they're giving you an order. Okay, so one tells you to, I don't know, swamp the deck. Okay, now I'm talking about pirates. Swamp the deck, I don't know. And the other tells you to clean the toilets. Well, how do you know which sergeant to follow first? Well, you're going to do the one that you see first or the one that you hear first. So the sergeant's orders that came first, in this case, left to right, you're going to do swamp the deck first and then the toilet. And then the last one, I don't know what comes after sergeant, general, lieutenant, sergeant, I don't know, private. Then you have the private's orders. And again, if there's two privates giving you a command, you have to do the one that was told first. And the one that was told first is the one that you see on the left. Okay. I don't know. I like to think of weird analogies like that. So let's try a few. I have 20 minus 2 times 3 squared. Okay, so I want to start with my G in GEMS. Do I have any grouping? Parentheses, brackets, fraction bars. No, I don't have any grouping. There's no general telling me what to do, so I want to jump down to lieutenant. And is there any exponents? Oh, there is an exponent. So I need to take care of him first. So 3 squared means 3 times 3. It does not mean 3 times 2. So 3 times 3 is 9. Now, everything that I haven't used, I want to just copy over. So I haven't used the 20, I haven't used the minus sign, I haven't used the 2, and I haven't used the multiplication sign. So I did the exponents. Now I'm on the sergeant level, level 3. Multiplication and division from left to right. Do I have any multiplication or division? Yes, I do, right here. So I want to do 2 times 9, and I get 18. I haven't used the 20, and I haven't used the minus sign, so I copy it over. Now I'm ready to do the last step in subtraction. 20 minus 18 is 2. Down here, I have subtraction and subtraction. So no G, no E, no M, but I am on this private level. Subtract and add from left to right. So there's two commands saying, hey, subtract me, and hey, subtract me. But you have to go and do the first one that you see. So on the left, you need to do this subtraction. 5 minus 6 would be negative 1. I didn't use this minus sign, and I didn't use this 2, so I'm going to write it again. Now I can subtract. Negative 1 minus 2 would give me negative 3. Okay, down here, I need to do grouping first. So I see a parentheses and there's only one thing in it. It's a 2. Okay, so it grouped the 2 by itself, but it's not telling me a command in here. It's not saying 2 plus anything or 2 times anything in the parentheses. It's just saying 2. Okay, so after grouping comes exponents. There's an exponent on that 2. It's a 3. So I need to take 2 times 2 times 2, which would give me 16. Sorry, 8. My bad. 2 times 2 is 4, times 2 again would be 8. Okay, so 8, and I haven't used the 4, I haven't used the minus sign, and I haven't used the 3. So what the heck kind of operation goes in between the 3 and the 8? While earlier they were hugging each other, and when two things are hugging or side by side, especially if there's parentheses around it, that means multiplication. So you can put a multiplication symbol there, or you can put parentheses there. All right. Now I see subtraction and I see multiplication. I need to do the higher order first. That'd be multiplication. So 3 times 8 would be 24. And I brought over the 4 and the minus sign. So when I take 4 minus 24, I get negative 20. And the last one. Now I see brackets and I see parentheses. So those are both grouping levels. Okay. Now grouping is not left to right. It's from inside out. Okay, so the furthest on the inside goes first. So I have my brackets, but within my brackets I have parentheses. So I want to do this grouping first. Carry over everything I haven't used. 1, I haven't used the minus, I haven't used the bracket or the 4 or the minus. 5 minus 3 is 2. I haven't used that bracket. So again, I have some more grouping. I haven't used the 1, I haven't used the minus. 4 minus 2 would be 2. And 1 take away 2 is negative 1. And in the bottom, these are the tricky ones because there's no parentheses or brackets, but it is being grouped. Okay, it's saying, hey, this fraction bar means there's hidden parentheses up here. You have to do this group of numbers before you divide by the bottom. So within the top, there's some things we have to take care of. We have to follow order of operations in this group of numbers, in this group of parentheses. So I see exponents, so I want to do that first. So I haven't used the 2 or the multiply, but 5 squared would be 25, and then drop down the minus 10. Now I have multiplication, I have subtraction, so I want to do the multiplication first. 2 times 25 is 50. Notice I am being extra precise. I'm writing down every step. I encourage you to do the same. 50 minus 10 would be 40. Okay, so I've done the top. The top was grouped together. Now look at the bottom. The bottom are numbers that are also being grouped together. Again, there's a hidden set of parentheses there. So I have to simplify this. I want to take care of the exponent first. 3 squared would be 9, and drop down the minus 4. 9 minus 4 is 5. 40 over 5, those can both be reduced by 5. 40 divided by 5 is 8. And then 5 divided by 5 is 1, which just simplifies to 8. Okay, if you have questions over order of operations, please feel free to ask. If fractions are messing you up, please ask about fractions. If you're still unsure about how to type things in on your calculator, let me know.